Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 17, 2025, so just about a week ago. This paper introduces a method that achieves up to 2.7 times faster training and inference for video generation. The paper is titled nablaNABLA, Neighborhood Adaptive Block Level Attention, and the implications for speeding up video generation are pretty significant. It tackles a major computational bottleneck in video models called the attention mechanism, which gets very slow for high-resolution video. Also, the authors shared their implementation on GitHub. It's built on the WAN 2.1 video model, and you'll find everything to get started, including clear usage examples and the command line scripts to generate videos with different nabla configurations. It looks really straightforward to test out for yourself. And on Hugging Face, you can find 3 14 billion parameter model checkpoints available for download, complete with usage examples to start generating video right away. So, let's dive into how this actually works. This first diagram shows the core of the neighborhood adaptive block level attention method. The goal is to create a sparse attention mask, essentially a cheat sheet that tells the model which parts of the video data to focus on. It starts with queries and keys, which are like the model's questions and the data's relevant answers. It first shrinks these down. Then, it uses a cumulative distribution function to find and keep only the most important connections, creating that sparse pattern. This mask is then applied to the full data, forcing most connections to zero. Now, to really understand the innovation here, it helps to look at what came before. These images show attention masks from an existing method called sliding tile attention, or STA. Sliding tile attention uses a fixed, predefined window to decide which parts of the video to focus on. As you can see, the resulting attention patterns are very regular, just these rigid diagonal bands. The problem is that this static approach isn't flexible. It can sometimes miss important connections in the video, which can lead to visual artifacts like blocky boundaries or even duplicated objects. So in contrast to those rigid patterns of sliding tile attention, this table really shows the real-world performance gains. It compares different methods on computational efficiency. We see columns for the method used, the sparsity, which is the percentage of connections the model ignores, and the inference time, or how long it takes to generate a video. The baseline takes over 8 minutes. But look at the NABLA method. At over 92% sparsity, it cuts that time down to just over 3 minutes. That's a 2.7 times speed up, showing how effective this adaptive approach is. Okay, so it's much faster, but what about the quality? This next table answers that, comparing model quality after fine-tuning. It uses metrics like the clip score, which measures how well a video matches its text prompt, and the V-bench score, a benchmark for overall visual and semantic quality. And what's remarkable is that the NABLA variance maintains scores nearly identical to the full baseline model. In contrast, the old sliding tile attention method shows a clear drop, especially on semantic scores. This shows you get that huge speed up without sacrificing the final video quality. But metrics only tell part of the story. The real test is what people actually think. So this table shows results from a human evaluation, where people compared videos side by side. They judged them on semantic alignment, so how well the video matches the prompt, visual quality, and motion naturalness. And the results are really compelling. In most cases, viewers rated both the NABLA and baseline videos as good, with over 57% choosing that option overall. This confirms that the sped-up model produces videos that are perceptually indistinguishable from the slower, original version. And it's not just about the final output. These plots show what happens during the actual training process. We're looking at training and validation loss, which is basically a score of how many mistakes the model is making, so lower is better. The green line, representing the NABLA method, is consistently below the blue line for full attention. This means that during training at a 512 by 512 resolution, the NABLA model actually learns more effectively, achieving better convergence. So it's not just faster in the end, it learns better and faster along the way. So, to wrap things up, the NABLA method represents a really clever solution to a major bottleneck in video generation. It tackles the massive computational cost of the attention mechanism, which is how the model decides which parts of the video are related to each other. By dynamically ignoring irrelevant connections, it achieves a huge speedup, up to 2.7 times faster, without any noticeable drop in quality. It works on a type of model called a diffusion transformer, a powerful architecture that generates video by reversing a noise-adding process. That's all for this week's Roundup. Thanks for tuning in.